This is typical reinforcement steel, non-grand spec for a foot wide wall. Now what you have is you have your four sets of lasers down the wall and you have your bars back here, a bar to give you a line for your wall, and two bars here, and these are set at 450 millimeters. On a grand spec wall I think they're at 290 millimeters. Now on a 9-inch wall, most people move these a bit closer to about 400 mil. Now concrete is very strong, and you can build things with just concrete, but what you'll find is that if you put the right steel in, the actual structure is 20 times stronger. The concrete is 20 times stronger with the right steel in it. So it's a trade-off. You can put loads of concrete and no steel, like you could put this a 3-foot wall and it should work fine. Or if you want to go down to a foot wall or a 9-inch wall, you need to put steel in it. Now the steel has to be in a certain place. Wherever the like say on this one now, because you're going to backfill the outside and there's going to be pressure from slurry on the inside. You're going to have pressure on the inside and the outside. Now the steel is placed 50 mil, which is about 1.25 inches, from the edge of the concrete. That's where it does the best work. The further in it goes, the less work it does, you know, or the further out it comes, the less work it does. 50 mil. Now on a building site they might leave you away with 40 or 60. But if it was 70 mil, they'd make you change it. Now, the reason I'm telling you this now is because a lot of people at the moment they're using a line of just L bars and they're putting them in the middle of the wall. Now, you're away, if you're in the middle of the wall, you're a long way from the outside, so you're actually doing very little good, you know. The other thing then, if you're putting mesh in there, mesh is very light anyway, so you're actually probably not doing any good at all with the mesh, you know. So like if you're doing a slurry, say a silage wall, and all the pressure is coming from one side, you'll see you only have steel on one side. But on these the pressure will be coming from both sides, so you need the steel on both sides. Now the other thing is a lot of people use welded sections. Now that seems like a great idea. You would imagine that, I'll just get the wire here now. You would imagine that welding the bars would be stronger than tying them. But what you find is that, so you have a loose, so there's two types of steel. One is mild steel and the other is high tensile steel. Now mild steel is just ordinary soft stuff like this. And what they do then to make it stronger is basically you just twist it and you turn it into high tensile steel, which is what these bars are. Now, I'll just do the exact same thing here now and I'll show you. So you just twist it, and what you end up with is something completely different. Basically like a nail. I've just got a bit of timber here just to show you. So now you see, very soft steel, and I was able to drive it in through timber. Now the problem is with this, it's strong because it's twisted. Now let's say here you have this bar is strong because he's twisted, this bar is strong because he's twisted. But if you weld the two of them together, you actually destroy the twist in both bars. If you weld, then you only go quarter way through this and you go quarter way through that to get your weld. You've weakened the bar by 25% each bar. So when you weld them, you're actually weakening the bars. Like that's why they should be tied with steel. No engineer has ever left the bar be welded on a building site, because when he sees this bar, he knows exactly what the strength of it is. When he sees a bar that's welded, he doesn't know how strong it is, so he can't trust it. Like. And the other thing, like I said earlier, is no engineer has ever designed a bar in the middle of a wall. They just don't do it because it serves no purpose. So, kind of recap, you need two faces of steel in the wall. One face is not sufficient. Now, if you have a very heavy layer of steel on the outside and you backfill it first, and then you're happy enough that when you put your slurry in, you push out against it, you may be okay. But I wouldn't chance it. I'd put the two layers in. If you want grand spec steel in it, what you do is you bring these much closer together, so about here, and you'd have 2 bars in here and 2 more bars in here, and that would be grand spec steel. So